My name is Mathias Angelico. I will be hosting this meeting, and I will be having today a panel composed of renowned scientists and engineers that will be addressing interesting topics and questions. So please welcome our speakers, Martín Fraguío, Pablo Struga, Cecilia Smoglie, and Juan Guerra. Thank you very much for joining us today. So I welcome you and thank you very much for being there. So without further ado, let's start with the agenda and the topics that we will be covering today. So first of all, I would like to say that we will be covering the different challenges, right? First, I would like to explore why, right? We need to start thinking about a change in an industry that has been here for more than 150 years, right? And this change is a revolution that is actually already happening. Needs to be thought, right? And we need to discuss what are the new trends, both globally and locally, here in Argentina. And of course, changes and any change, right, require to sort challenges, but also bring new opportunities. So we'll be discussing about these new businesses and improvements in the standards and the status quo, right? Finally, we will conclude and spend some time answering some of the questions at the very end of this webinar. So again, for those who are just joining us, please post your questions in the chat, and we will be answering at the end. So for more than a century, right, electricity was produced in specific locations and distributed among us in different ways, right? Energy consumption has always been associated with the economic growth of global and local economies. And as you may know, it is evident because it's something that we are, well, every time we turn on the TV, we see the effects, right? Our lifestyle and the way we consume and use energy is causing changes, not only in the climate, but also in the species worldwide, right? Therefore, we need to start thinking new ways to produce, to harvest, to distribute, and consume energy in order to reduce this negative impact that they have in our planet. So for the first set of questions, or the first part of this meeting point, I would like to introduce Martín Fraguío. He's a professor at the Masters. We have a joint master between ITBA and KIT in Energy and Environment. And he's also a director of the Carbon Group, Agroclimatic Solutions. So Martín, thank you for being here. The first question for you would be, based on the commitments and all what has been happening since Paris Agreement in 2015, how far are we from accomplishing the COP21 objectives?
Thank you, Mathias, for your question. It's a very important question because I think the first thing to understand is that the Paris Agreement, or the Paris Accord, is the most important agreement countries have reached within the last half century at least. In this agreement, the main aspects is that countries commit themselves to decrease their greenhouse gas emissions. And this strongly affects the power and the energy sector in general, because 80% of global emissions come from burning fossil fuels. In this agreement, also, countries, in order to reach those commitments, they design what are called the nationally determined contributions. That is the second bullet point seen there. They're called the NDCs. And unfortunately, going back to your question on how far we are from accomplishing those COP21 objectives, which is to reach zero emissions by 2050 and to maintain global temperature between 1.5 degrees Celsius and 2 degrees Celsius above the highest level of today, which is very difficult. So today, nationally determined contributions, if added all together, would take us not to 1.5 to 2 degrees, but more from 3 to 4 degrees. However, the COVID crisis has shown the importance of working on the aspects of common goods on Earth. And it has shown how a systemic crisis can grow very rapidly and affect everyone on Earth and destroy actually everything that is functioning. And so what we've seen during the last year is how many countries have committed themselves to reach carbon neutrality, starting from Sweden, the UK, the European Union, China by 2060, and most probably we'll see something of that type in the US probably during the last couple of weeks. The same has been happening with companies. Very large companies have been committing themselves. So what we're seeing today, and this started at COP21 in Paris, is that today the world of business, the large business organizations and companies in general, instead of backing off from the commitments of climate change, what we're seeing is that they want to lead this and to invest more into solving humanity's largest problem. And I think it's worth following what the International Chamber of Commerce, the World Economic Forum, and the World Business Council on Sustainable Development are doing. Also what some governments are doing. And I think it's interesting now to see the new presidency of the European Commission and now the government of the US, but also to follow what's being done from Brazil and the other countries of Mercosur, including Argentina. And of course, the UN organizations, that this is where the whole climate change debate occurs. Thank you very much, Mathias.
Thank you, Martin, for your thorough answer. The next for you, and it's on the same line, right? But more focused on our country, in Argentina. So what is the role of Argentina on climate change, and what are the measures taken by our country, by Argentina, to reduce its emissions, to reduce the impact?
Right. It's a really important question because we live in Argentina and we develop our activities mainly here. So Argentina is not a large emitter, it's around 0.3% of global emissions. However, since we don't have a very large population, when we consider per capita emissions, our position is slightly higher than other countries. What we're seeing here and thus on this presentation, on this slide, is the current inventory of Argentina. And we can see that energy is 53% of our total emissions. Second come agribusiness, or what in the terms of climate change is called AFOLU, which is agriculture, forestry, and land use. And then other activities like industries, that doesn't include power, of course, it doesn't include electricity, but it does include burning of other fossil fuels within the industrial complexes or facilities, and last of all, residues. So Argentina is actually trying to work on these sectors and to, next slide please, and to decrease and to decrease their emissions. And that's why since 2016, that was the year where the Paris Agreement was reached, Argentina has been presenting the different nationally determined contributions. And the last one was presented last week. And with this one, Argentina aims to reach carbon neutrality by 2050 and also to decrease our emissions to 359 gigatons of CO2 equivalent by 2030. This is probably not a large number in comparison with today's emissions, but what it means is that Argentina will continue to go down to avoid emissions that would have happened due to its normal course of business or business as usual type trend. So actions here are renewable electricity, which all companies need to reach 20% of their power supply to be renewable by 2025, and this is a law that was approved in Argentina just 2 or 3 years ago. Second is biofuels, which in the case of ethanol I'm sorry, it's misspelled. There's an H missing there. The current blend is 12%, and we believe that it might go still up, as it's the case of Brazil, where it's today around half the total gasoline supply is ethanol, and biodiesel is currently 10%. Of course, another aspect that's important is to stop deforestation, because when we consider the land use emissions, it's actually deforestation that has become really important. So these are actually the main aspects having to do with our commitment and our activities for the future.
Okay, and is there any like basically what's the effect on the climate change we can see in Argentina, right? And which are the risks in our country?
Yes, thank you, Matthias. This is very important because Argentina is a developing country, and for us, you know, as a Institute of Technology, as an engineering and a group of engineers, and it's really important to understand what are the effects and the risks countries have when we think about climate change. And as we can see on this, also published by the Argentine Ministry of the Environment, there will be increases in average temperatures, in annual average temperatures around the country, and this will mean hydric stress, mainly in agriculture, but also in the sources that supply water, fresh water for human consumption. So there might be, as it can be seen on the western side of the map of Argentina, potential water crisis in Mendoza, San Juan, and the Comahue region. Also, glaciers are withdrawing, and there is a loss of these type of ecosystems. And on the right, on the eastern side of Argentina, we can see also higher frequency of extreme floodings and precipitations. And so we understand, and of course there's the effect on rising sea level on our lower coasts in the eastern part of the province of Buenos Aires. So it's important to understand that from an engineering perspective, it's really important that countries understand how they must adapt and how technology must be developed, and investments must be done in order to adapt ourselves for these new situations and their risks.
Thank you.
Thanks again, Mathias.
Yeah, and like going down that road, right? You were talking about like last sentence, political maybe changes, right? And market changes, technology, all what is needed to overcome or like to avoid having these effects and avoid these risks, right? Or reduce its impact at least. Based on your experience and in your perspective, what are these political changes and market changes that need to be maybe implemented in Argentina to move forward, right? In this energy transition, you were talking about like 20-25% renewables, zero emissions, etc.
Yes, I think that's a great point, and it's where actually the most complex set of questions and answers lie. And it's really difficult for those decision makers, mainly in public positions in government, to understand the complexity of this. But there is consensus today globally that the first thing is that Argentina needs to set a price on carbon. This is something that many countries are trying to do. Many companies globally are putting a price on their carbon emissions so as to embed those emissions as negative externalities within their balance sheets and try to decide if they should invest in these type of technologies or instead they should choose other. But we think that is one of the things that Argentina, following the example of many other countries, should try to decide that. And because behind putting a price of carbon is the principle that those that pollute or emit should pay, and those that make benefits, that create or invest in positive externalities, in activities that not only benefit themselves, or they probably not, they have no direct benefit for those companies or those people, how they are creating a benefit for the rest of humanity. The second question in Argentina is how to limit fossil fuel subsidies. This has been extensively debated at the International Energy Agency and other institutions, and it's something very hard for Argentina to do because we're an importer, unfortunately, of fossil fuels. Then we need to promote investments in renewable energy. There are a few laws in energy efficiency, but there is a lot of room for that to improve as well. Then we need to promote negative emission technologies, like, for example, soil carbon sequestration. That is one of the key aspects that humanity needs to develop, and this was installed in 2015 at the Paris Accord, and since then there has been a great movement around this. We are part of a team developing this technology for the FAO, the Food and Agriculture Organization of the United Nations. It's called the REC-Soil, the Global Soil Recarbonization Program, that will be basic for humanity reaching these goals of maintaining atmospheric temperatures between 1.5 and 2 degrees. And last of all is to support all the initiatives to circularity in business models and support companies so that they can become more effective in design and in production and, of course, in consumption of the goods that we discard as residue or as used products. So we think these new value chains will be very important for Argentina, not only aligning itself with these sustainability goals, but also with becoming a more developed country and leave behind these times of recession. And we think it's a challenge for us engineers to work on this. So, thanks again.
Great answer. Thank you very much, Martin. To go to the next topic, or like transition to the next topic, I would like to like comment, or at least show this in this slide, right? That apart from the environmental perspective, we were like chatting and discussing with Martin. We can see that there is a kind of a grid modernization, right? We see that distributed generation and smarter networks will allow now the users to have backup power, reduce the energy billing, right? Demand charges, support the grid, right? With their batteries when power is needed, and defer maybe the investments from distribution and transmission companies to support the grid. But well, this paradigm, right, starts to change when power plants, as we see in this slide, go from like a centralized, right, localized in specific places, and now are substituted by a plethora, right, of assets, which are distributed among the network. And these assets could be combined and used for self-consumption, generate revenue, or maybe provide services to the distribution and transmission operators and companies, right? And this distribution or these distributed resources allows not only to reduce the losses associated with the transportation of energy, but also to defer, as I said before, investments needed to expand the network. So to introduce a little more about like the technology side in this aspect of going towards energy 4.0, smarter grids, and reducing the impact, right, with a more modern network and the way we use and consume energy, I would like to introduce Pablo Struga. He's an electrical engineer, graduated from the master's ITBA KIT. He's currently working as a project engineer in Solar Latam. So Pablo, I welcome you. And I have a couple of questions for you. The first one is, well, based on your experience in utilities and as a solar engineer in the PV sector, right? What are the trends you see in terms of using residential and commercial as well, solar PV, to support the grid?
Okay, so thank you, Mathias, for the introduction. And first of all, I would like to thank you all for being here. Especially, I would like to thank ITBA team for giving me the opportunity of participating at this meeting. So now let's see the actual trends regarding PV technology. As you can see, there is a sustainable increase in the installed PV capacity. This can be explained by the decrease in the main component costs and the development of supportive measurements and policies that help PV deployment. Furthermore, projections for 2050 show that the cumulative PV capacity will continue growing. You can see that in the next slide. Now, the share of the utility sector is about 50 to 60%. And in the future, this share will reach 60 to 65%. But the interesting thing here is that the remaining share is all for on-site generation, meaning millions of end users having their own PV systems on the rooftops. So from my point of view, we will see a rapid increase of PV distributed generation capacity on the residential and commercial sector. Commercial and industrial will present the largest growth, as the compatibility of load and PV generation profile will make it easier to get savings on the electricity costs. Residential will follow rapidly once the economy becomes attractive for them. Still, good prices and financial products will be needed, and so also the customer engagement is also essential to walk through this transition. And of course, electric vehicles, IoT, and events like COVID-19 will accelerate the transition to decentralized energy. In my personal experience here in Argentina, we met a lot of customers showing a deep engagement with the environment, looking up to make their small contributions by installing a PV solution on the rooftops. And now I would like to show the Argentina scenario. Sorry, can you put the go back to the yes, that one. Thank you. As you can see, in the last years, there was a great increase in PV installed capacity, mainly due to the utility scale project. This was possible due to the Renovar government tenders. The installation of PV rooftop capacity was possible thanks to the bill 27424. Still, there were not enough financial incentives for the end users. So there you can see why it's so important not only to have good components and reach good cost in technology, but also give the end users financial incentives so they can buy their products. And if you see some numbers, there are more residential cases than commercial installations, but if we see the capacity share, commercial and industrial sector takes 2/3 of the total capacity. That you can see that in the next slide. So here, so we are talking about that Argentina has now more than 3 megawatts of PV rooftop capacity installed. And I think that, of course, this is new for Argentina if we compare it to other countries like Germany or Australia. So we are doing our first steps in what is distributed generation, but there is a long way ahead. We can walk, and there is also, like I mentioned before, after PV rooftop, it comes electric vehicles and IoT, and this is going to diversificate the grid, and we'll need to have to improve the technology here in Argentina, the grid technology, so we can afford all these components.
Great, thank you, Pablo. And shifting towards to more personal questions, what
Yes.
has motivated you to study electric engineering and then pursue the joint master in Germany? And how do you think ITBA prepared you, right, for the current tasks you are developing?
Okay, thank you for the question. My interest in energy topics started at high school. While doing my studies at ITBA, I had the opportunity to get more related with the energy sector. After finishing my bachelor, I had the opportunity of working at the generation and distribution energy sector. This was a great experience. At that moment, it was clear that the future of the energy sector would be led by renewable energy. That was the point where I decided to join the ITBA Kid Master. This was a great choice as it gave me the opportunity to start working at the PV industry. ITBA gave me the academic knowledge during bachelor and helped me to start my career as an engineer. And it also gave me the opportunity of studying my ITBA Kid Master in energy technology. In addition to technological knowledge, this experience gave me many other tools and skills that helped me to develop my actual career. And I can say that it also had a great impact in my personal life.
Great. I'm glad to hear that you had a great experience in both, right? Here as an electrical engineer and then with the joint master. And going back to more like, again, to technology and your business or like engineering experience, right? We see that not so long ago, consumers around the world now are producing, as you said, right, with distributed energy, with solar, rooftop, and now we see a lot of battery energy, right, storage at homes, like Powerwall, Tesla. That's one brand, like, to name it. And there is globally there is an increase in the number of utilities offering incentives to install, for example, rooftop solar PV, battery energy storage, and the idea. Well, my next and last question for you to understand the local trends in Latin America and Argentina regarding this topic is basically what are the business models that are thriving in the region regarding solar rooftop, and what are the main challenges Solar Latam, the company you are working in, is facing to introduce these innovative solutions in the energy sector. You named some of the network and prepare the network, but I think there could be many among us. I mean, we are making the first baby steps, right? As you mentioned.
Yes. So typically, what I see is that the feed-in tariff is really common on South American countries. The Argentinian law is something different. It has a special incentive for the energy. It's like the net metering, known as net metering system. But it also the law was prepared for giving some financial incentives coming from the government, but they weren't totally developed. And what I see is that we need as the tariffs here in South America are structured. We need to make good laws so that we can help final consumers get them the possibility to get the technology. It's different, for example, from Florida, where we also Solar Latam has an office there, because they have residential users have also different costs during the day, electricity costs during the day, so that can help you to have a different business model, like the Tesla battery, for example, to storage energy when the moment where when energy is expensive, and then sell it when it's cheaper. You can do that here in Argentina. And so going to the second question, I would like to talk about a little bit about Solar Latam. We are a Latin American company, and we have main presence in Argentina, Chile, Panama, Costa Rica, and Florida. And what we like, our customers are from the residential to the commercial sector, and we always offer the turnkey solution. What we see, as I was talking before, is that here in South America, distributed generation is new for end users. So we want to make easy for our clients to select the PV system for their homes. So we are developing a web app platform where customers can rapidly get a quotation and so they can know how much it's going to cost their installation. And the idea is also to incorporate all the financial benefits available in the market for each country. And also they can get a detail of the solution components and schedule a meeting with our techniques. The client can also buy the solution 100% online. So everything is there and it's easy for our client. That is what we think is needed right now in the market, and is what we are innovating right now.
Thank you, Pablo, for your answers. It is really interesting how a company is doing not only in Argentina but in Latin America, and trying to push and move forward with this. And I can think many challenges, right? Because we need to make sure the grid is stable, right? It has the correct reliability levels. So what usually happens is that many of these generation assets like solar PV, right, they are intermittent, and we need and we spoke about energy storage and batteries, but there is like a huge development now in hydrogen. And for that topic I would like to introduce Dr. Cecilia Smoglie. She's a professor at ITBA and director of the Masters ITBA KIT in Energy and Environment. Thank you, Cecilia, for being here with us. And my question for you, Cecilia, is why is that hydrogen is suddenly a subject of great interest among engineers, among scientists nowadays?
Yes.
Yes. Yeah, we can hear you.
I am going to summarize the evolution in the interest of hydrogen. You see, at the beginning, hydrogen was used for industrial, for food and chemical processes. But later, hydrogen was of interest for electrical vehicles by using fuel cells to convert hydrogen into electricity, and batteries to store the electricity coming from the fuel cells, and also the electricity produced by recovering the braking energy of the vehicles. But the fuel cells itself is not clean. the production is not green for the environment. The interest has also to be focused in the exceptional combustion properties of the hydrogen. Hydrogen has a high octane number. This allows higher compression ratios, which improves the efficiency of internal combustion engines. And hydrogen has also broad flammability limits. It means the combustion can be performed with less fuel and more air, which enables zero emissions, no carbon oxides and no nitrogen oxides, only steam water. So these properties as fuel encouraged the use of hydrogen as fuel for the power plants. This is good, but not enough to stop the global heating. For a transition to real free emissions energy, we have to extend the use of hydrogen as fuel in all internal combustion engines. First, for heavy transport, like trucks, ships, airplanes, and later also in automobiles and light vehicles. Fortunately, this transition has already begun.
Great, and a question that comes to like I mean to anyone that listened to you after this explanation is how hydrogen can be produced and stored, right? In which manner? So maybe you can explain us about that.
This is also a key subject. Hydrogen is mainly available in the nature in hydrocarbons and in water. And from hydrocarbons, we obtain the so-called gray hydrogen by using steam reforming of coal or natural gas, which produces carbon residues, or the so-called blue hydrogen by steam reforming of natural gas only, no coal, and carbon capture and sequestration, the so-called CCS procedure. These procedures are not sustainable because the sources are not renewable. They consume high energy, leave carbon residues, and produce CO2 emissions. A third possibility is to produce the so-called green hydrogen, which is obtained by using only renewable energies in any of the following two processes: by steam reforming of bioethanol or biomethanol with total carbon capture and sequestration, or electrolysis of water, which is carbon-free and with an average efficiency of 0.65. We need, with electrolysis, 9 kilograms water plus an energy of 50 kilowatt hour to obtain 1 kilogram hydrogen, absolutely carbon-free, no emission but water, and later combustion of the hydrogen only emits steam water. Now, related to the production is the storage. The storage is a very important point, and this can be storage as hydrogen can be storage as gas, liquid, or hybrid.
Great, thank you, Cecilia, for your answer. And my next question to you is about your research, right? You have been doing on this topic. So has IDVA, the university, research and development on these technologies in hydrogen?
Yes, actually we started with water electrolysis and related hydrogen technologies in 2002, and our current projects are hydrogen production, storage, cleaning, and combustion. We have our production technology is very special because we manage the self-pressurized electrolyzers. That means we produce hydrogen under pressure, and we don't need posterior mechanical compression, which allows a big reduce of energy. And we can produce hydrogen between 30 and 500 bars. And we have installed such electrolyzers in Antarctic, in an experimental plant in Patagonia, in the National University of Córdoba in Argentina. In IDVA, we have one electrolyzer for 200 bars. And in KIT, we have installed just a small lab-scale electrolyzer to produce hydrogen up to 500 bars. We have also made some advance in storage technologies by using a very innovative cold tube tank to store hydrogen, oxygen, or gas. And these tanks were tested up to 1,000 bar, and very light. They are very light and very safe compared with the usual storage tanks. And as fuel in internal combustion engines, we can control the combustion in an Otto cycle to obtain zero NOx emissions, zero carbon because it's carbon free, and also zero NOx emissions. That means we can afford zero contamination by using hydrogen as fuel.
Perfect, perfect. Thank you. I think it's a really interesting topic to follow because this is the future, right? In terms of clean energy and energy storage, right? You can storage the excedent of energy or the excess in and produce hydrogen with clean energies, as you mentioned. So I think this is a really interesting topic, and there are, I can think, right, many opportunities to leverage existing resources in our country and deploy cleaner ways of generating energy. And as Argentina, as a country, in Latin America, but Latin America specifically, and Argentina has significant geothermal resources, so that could be used for this purpose. So for the next set of questions, we have invited Juan Guerra. Juan is a chemical engineer, master student, currently ongoing with the KIT masters along with IDVA, and he's working on geothermal projects. One project specifically at Salto Grande, Argentina. So, like Pablo, well, first welcome you. Thank you for joining us, Juan.
Thank you, Mathias.
Yeah, and like Pablo, well, you have chosen this IDVA and KIT to pursue, right, your master's degree. So why have you chosen energy as your career path? And tell us a little bit more about this topic that is your thesis, right? Geothermal energy. So yeah, that will be my first question for you.
Sure. So thank you for your introduction. And first of all, I would like to express how grateful I feel to be taking part of this conversation today. And going back to your question, at the moment I graduated from chemical engineering 3 years ago, I was already working in a very small startup doing energy consulting. This was a time in the country when energy costs started rising at a high level, so industries and big consumers began looking for ways of making quick cost savings. So we did that. We developed different approaches and managed to efficiently decrease the energy consumption up to, for example, 30% annually. And I worked there for about 2 years and became very interested in these topics, such as energy efficiency, energy management, and renewable energies. And also, I knew there was a huge potential in the country for future developments. So I decided I would take a step forward and began looking for attractive postgraduate programs. I soon came across with ITBA's Energy and Environment Master Program, which I had never heard of before. And what I liked the most about it was the possibility of obtaining a double degree, both in Argentina and in Germany at the KIT, as well as, of course, getting to study there. I had only one interview with Cecilia, and that was it for me. My semester at ITBA went well, but by the moment I was supposed to fly to Germany this year to do my second semester, the pandemic had already begun. So I had to stay home, and as time went by, Cecilia spoke to me about a master thesis proposal coming from KIT. And this was about geothermal energy. So of course I accepted the proposal and soon came in touch with my thesis tutor in Germany. And in particular, the work is about the optimization of a power plant control system, which uses a geothermal stream as heat source. And I've been working on this for 6 months now, and I will present it in a few weeks.
Great, thank you, Juan. I think it's really interesting the way you have developed, or you are developing your career in this interesting topic. And I would like to know more about the Green Smart Grid project in Salto Grande, Argentina. Tell me more about that and what are exactly doing, right?
Of course. So one of the largest hydroelectric dams in the country is Salto Grande, which is in fact shared with Uruguay. It is located in the Uruguay River between two large cities, Concordia in Argentina and Salto in Uruguay. And a green smart grid project is expected to be constructed around the dam's reservoir and to integrate different sources of renewable energy, such as solar photovoltaic, wind, biomass, and of course, geothermal. And this could enable the development of a local smart grid for clean, distributed, and interconnected energy, while at the same time serve as an experimental platform for a Latin American training center. And throughout the past few years, many of the master program's thesis work were involved in the application of some of these types of renewable energy sources in the country. So there is already a big contribution to this project. And in fact, due to my involvement in a thesis on geothermal energy, I had the opportunity to start working for GTN, which is a German consulting group specialized in geothermal energy supply. And GTN showed special interest in this project, and luckily I have been able to start working on it too.
Great, congratulations for you then. And based on your experience, right, working in this project, as you mentioned, tell us more about the potential of this area, Salto Grande, in terms of geothermal energy generation.
Okay, so through the last couple of months, we began evaluating different applications for the thermal resources in Salto Grande. We have to understand that these resources are coming from the Guarani aquifer, which is the second largest water aquifer in the world. So Entre Rios, which is the province in which Salto Grande is located, has a huge volume of water available. And the thermal water in this area, however, has a relatively low temperature of around 40 to 45 degrees Celsius. So taking this into account, the applications we considered are related to the main activities in the province, which are agriculture, tourism, and wood sawing. And some examples of these applications are the greenhouse heating, open field heating and irrigation, hydroponics, residential heating, and of course, wood drying. And we are currently working on a project involving this last application, which is wood drying. The idea is to construct one big drying chamber that could be used by all small and medium factories in the area, which cannot afford their own gas-fueled chambers.
Great, great. Thank you, Juan, for joining us, participating today, and sharing your experience both as a student in the masters and of course as an engineer that you already are, right? So we will start the QA session. I hope you have enjoyed with the topics and discussion we have proposed today. We encourage the audience to post your questions in the chat in case you haven't done it. And we will start, well, we will grab and pick a couple of them and ask our panel. So I have some here from Santiago. The first question I see here is, and maybe for Cecilia, probably for Cecilia, why is hydrogen not produced at the same rate as conventional hydrocarbons, right? It is a good solution for our pollution problem. So why is not produced at the same rate as maybe other sources of energy, right? Why is not adopted? Maybe that's the question.
Yeah. Perhaps because up to now it was not investigated, and it is at the very beginning more expensive, different technologies, not usual. We had a big competition with oil industry, but this is no longer so. Today, the main theme of the world is not COVID-19, it's hydrogen, then COVID. Therefore, don't care. You will use only hydrogen when you became a man. I mean, I don't know if you are a man. Okay.
Yeah. Yeah, it was Santiago. Yeah, so Emilia is asking something similar, right? I mean, about hydrogen, and I think it's interesting for you, Cecilia, as well. Is it possible to use hydrogen for home energy production or to produce at home? Like, do you imagine like kind of maybe we were talking about distributed energy generation, right? So imagine in the future, people, instead of generating with solar PV, having like kind of electrolyzers at home and generating hydrogen for their self-consumption. Do you think that's possible? That could be the future?
No, I don't think so at the moment. At the moment, I know electrolysis technology is quite complicated. That is not good. It is not good to think about something like that at home. But what I am sure, you will have hydrogen at home. Don't worry. You will become hydrogen per tubes, like gas. But I don't think you will produce hydrogen at home, not with nowadays technology.
Okay, perfect. Thank you, Cecilia, for that one. So the next question from Jose Luis. Thank you, Jose Luis. Maybe for Martin, what are the pending issues in order to reach a real energy transition to clean and renewable energy in Argentina? What do you think are the pending issues we need to tackle, right? Depends on political or scientific will, maybe. And there is a lot here. He has made a really complex question, but what is a pivotal energy sector, right? Residential, industry, transport. So maybe let's do a brief answer, but focus on what are maybe the pending issues and what is the first to tackle, right, to solve those issues.
Yeah, I think it's a great question, because in the end, energy is the single most important aspect of human development. When we look at energy consumption, or energy-related emissions, always GDP, per capita GDP, per capita income, wealth, and other indicators of sustainability and of well-being are related to that. And I think one of the problems with that we still carry in Argentina is to have, because of still being a developing country with large structural problems like inflation, climate, exchange rate crisis, political crisis, and many other things, we don't have time to focus and to plan adequately how we would like to continue to move these sectors forward. So I think we still need a debate as society. And I think engineering or technology is where this should start. We should start by analyzing how that energy transition can be designed for an improvement of Argentina as a whole, and making a contribution globally as well, not just for our sake, for our benefit, but also to think it globally. And I think that we need to do that, and that's one of the things that we discussed at this Masters that Cecilia leads. That she's a great leader, and with the support from KIT in Germany, we have great debates on how developed countries and developing countries can solve this, which is part of Jose Luis' question.
Thank you, Martin. And for our last question, and maybe for Cecilia as well, is Sergio is asking, what is the main obstacle of the power to gas technology, right? And what is your opinion about convert hydrogen into methane?
Emilio, who is he? Wait a second.
Sergio, sorry.
Sergio.
Yeah.
Two things. One, the main question of using gas for power energy, for power plants, is the contamination. Contamination, because gas is carbon. Therefore, the combustion of gas is a high CO2 emission. Like Martin said us, I don't remember, perhaps Juan Pablo, 50% of the contamination comes from energy, and 40% from the agriculture. Therefore, energy had to turn to clean energy. And the question is not how to convert hydrogen into methanol, no. How to convert methanol into hydrogen, which is what the world is doing from the beginning. We obtain hydrogen from methanol, other from coal. And this is not good, because we need coal and gas for other things and not to obtain hydrogen. And because this transformation of methanol in hydrogen lead to a lot of residues of carbon and a lot of energy consumption. It's contaminating and is using a non-renewable energy source that we need for other things, not to obtain hydrogen. Hydrogen had to be obtained from water only.
Perfect. Thank you. Thank you for your passion, Cecilia, and for your experience, your knowledge in this topic. I can tell you have a lot of experience, and thank you for sharing that. All of you guys, thank you for being here. I thank also the people who is behind this. I mean, our audience who was interested from the very beginning and sent these wonderful questions for our panel. And I want to thank ITBA as a university and the School of Innovation for hosting this meeting point.